Hello, my name is Jenny Gardner. I'm an academic coach here at SNHU, and welcome to this guide on combining functions. We're going to begin with learning how to combine functions. Then we're going to talk about notation. And finally, we'll go through some examples. So how do we combine functions? You could have two functions. You could have more than two functions. Let's say you have two functions. Well, combining functions just means to apply the mathematical operations. And what that means is using addition of functions, subtraction of functions, multiplication of functions, or division of functions. And it's similar to how you would be able to use numbers, but this time you would have entire functions that you're using. After you've figured out what you're adding and subtracting or multiplying or dividing, then you have to combine all your like terms to find your final solution. And additionally, you can graph it as well to look and see what it looks like separately and what it looks like together. Below here, I have two different versions of the notation with an equal sign between each one. On the left, we have the function f plus g for x. On the right, we have f of x plus g of x. It means the same thing. Either side, notated either way, means the same thing. You're adding the two functions. Subtraction. F minus g of x is the same thing as saying f of x minus g of x. It means that you would be subtracting one function from the other, and you have to be really careful with subtraction to look for the negatives and see what stays negative, what becomes positive, what's going to happen when I distribute the negative. So we'll go over that in an example. We also have f times g of x. Well, that means the same thing as f of x times g of x. Totally fine to use multiplication of functions. And then finally, division. And all of these, we want to be extra careful to pay attention to which letter comes first. In this case, it's f divided by g. But if it was the other way around, g divided by f, we could do that too. But f divided by g of x is the same thing as f of x divided by g of x on this side. So notation looks like this. It's telling you to perform these operations, these mathematical concepts of addition, subtraction, multiplication, and division on the function. Well, now we get to try it. I have two functions up at the top here. We have f of x is negative x minus 4, and we have g of x is x squared minus 16. So we have two different functions there. And the first thing it says is to add them. Add f of x plus g of x, and we notice the order says f plus g. So we're going to take our negative x minus 4 and add it to x squared minus 16. Addition is probably the easiest one of the four because you're not having to worry about any negatives. You don't have to distribute everything. We're just adding these together. And when we do that, we would find negative x minus 4 plus x squared minus 16. And that's how we performed the addition. And now we need to combine like factors here. So if we look at this, x squared is by itself. There's no other x squareds in here. There's no 2x squared or 3x squared. There's just one x squared. So we're just going to put x squared. And then it says minus x minus 4 minus 16. Well, the x is all by itself as well. It can't be combined with x squared, and it can't be combined with numbers. So it's just going minus x. And then we have the negative 4 minus 4 and the minus 16. Well, minus 4 minus 16 becomes minus 20. So those are like, and we're going to combine them. And this would be our answer to this problem. Now from here, you could factor it, you could solve for x. We're not going into that in this video, but look out for more in the future. The second example here, I said g minus f. G minus f, okay? So look at the order of that. G of x minus f of x. So we start with the g. So we're going to say x squared minus 16 minus, because we're subtracting the other function, negative x minus 4. So you'll notice that I put that in parentheses. And the reason I did that is because those negatives don't stay negative if we're subtracting them. When you subtract a negative, it's the same thing as adding a positive. And if you don't know those rules, I would go and look them up. Look up the rules for negatives so that you can study more. So if we look here, we have to distribute the negative to both the negative x and the negative 4. So this is going to be x squared minus 16 minus a negative x minus a negative 4. And both of those turn into adding a positive because of the little rule I mentioned. So that means that this becomes x squared plus x minus 16 plus 4, and now we get to combine the things that are alike, and we find x squared plus x minus 12 is our final answer here. Remember, you can go back, pause, rewatch, retry these problems, okay? So if you are stuck on any of this, go back and practice. Go and try it with your own problems. Come back, watch the video if you're still stuck. All right, so let's try combining functions with multiplication. So we are looking here at taking f of x and multiplying it by g of x. Okay, so we have negative x minus 4 multiplied by x squared minus 16. Well, when we have two parentheses, two functions that are multiplied together with 4 different values inside, we have to make sure we have some way to methodically work on this and make sure that it is following along and using every single value in every parentheses against the other. So what that means is we're going to use the FOIL method. First, outside, inside, last. So first, outside, inside, last. And when we're looking at first, outside, inside, last, first means the first values here. And so we'll have negative x times x squared. Outside is going to mean the ones on the very outside. So here, negative x and negative 16 of both parentheses. So it'll be negative x times a negative 16. Inside is the very inside of the parentheses. So that will be negative 4 and x squared. And last are the last values here in the parentheses. So that'll be a negative 4 and a negative 16. So negative 4 times negative 16. All right, so now we get to solve for those. Switch back to my other color here. All right, negative x times x squared is negative x to the third. A negative x times negative 16 is plus 16x. Negative 4 times x squared is negative 4x squared. And lastly, negative 4 times negative 16 is a positive 64, I believe. So if we solve this by combining like terms, they're actually all combined the way they can be. There are no more like terms here. However, we can rewrite this from least to greatest in exponents. So we could say negative x to the third minus 4x squared plus 16x plus 64. And that would be the solution for our multiplication. The very last thing we're going to do here is divide. Function f divided by function, you know what? I flipped it around on this one. This should say g divided by f. Because if we look over here, g is being divided by f. So we want them both to match on both sides. So we're going to say that I had a little typo there and I put them in the wrong order. So we're going to divide g by f. So g is x squared minus 16, and that's going to be divided by negative x minus 4. So thinking about what we can do from here, we have to think about how we can reduce this to its factors. So x squared minus 16, how can that be reduced to its factors? And if you know, take a second and pause it and try and figure out what you think the factors of x squared minus 16 would be. So x squared minus 16 is called a perfect square. It's a perfect square polynomial. And perfect square polynomials factor down very nicely. If we look at this and we say x squared minus 16, what could that mean? Well, it breaks down into x minus 4, x plus 4. And you could take the time and factor this out with the AC method and grouping and figure that out as well, or use the quadratic equation. But either way, it's going to factor out to x minus 4, x plus 4. And you can check that by taking this and reversing it and multiplying them with FOIL and making sure you get x squared minus 16. On the bottom, we can't factor that out because it doesn't have an x squared necessarily, but what we can do is what I call reverse distribution, where we remove out something that's alike in both the x and the 4. And what that right now, if we look at this problem, what that shows us is that they're both negatives. And so we could say a negative 1 comes out, and we would be able to leave in x plus 4. And so the negative 1 would have been removed from both sides, the x and the 4, and it allows us to do something. And the reason this is handy is because now we can eliminate the x plus 4 here and the x plus 4 here, which would then let this equal x minus 4 divided by negative 1, or if we divide by negative 1, it's just going to distribute that negative. So we're going to look at negative x plus 4 as our final solution. Every time you get a division situation and you're factoring out with a polynomial, then you're going to get a different answer. And it's going to take some practice to get there, but hopefully this has helped you learn about combining functions. Congratulations, you made it through. Today we discussed combining functions with some examples along the way. Thank you for watching Academic Support Guide on combining functions, and please read the video description for further resources.